Alright, this is the part we're going to be working on for this module. So we're going to do the turning on this side and this op. We're going to flip it. We would bore soft draws at the machine. We won't program that in Mastercam. We can either use one of our, we can do G71, or we can use one of the Haas quick codes to do that. So we'll leave that alone, but we would grab it with soft draws in this diameter, flip it, and then we'll face the remaining stock, and then we'll use the live tooling to drill and circle mill these holes out. So that's the process plan for this one. So let's get started. Alright, so let's import this model. So I'm just going to go to open here and go to my desktop. I already have it downloaded. I'm looking for step files. Make sure if it's not there, you're looking for the right file type. So there it is. Hit open. And there's our workpiece. So notice it's not aligned to the top plane correctly. Okay, so we go to top view, it's not right. We need to translate it. We could have done that in the initial open screen, but I find it just as easy to just move it here. So select everything, dynamic, and I'm going to select the diameter here, rotate the workpiece -90 or 90, like that, and then select the center of the dynamic gnomon and bring it to the top plane. So then if we go green check and top view, it is aligned properly to the coordinate system of top. So we're good there. Let's go to a new machine, machine, lathe, the generic Haas ST, and let's define our stock. So we'll go into our stock settings. We're going to be using 3-inch stock for this, probably, let's say 2-inch for workpiece for now. Let's preview lathe boundaries. That'll work for us. Then beyond that, we're good here. In the chuck jaws, we'll go parameters here from stock, grip length, let's say 1 inch, and let's see where that gets us. Alright, a little less than that we'll need, so let's go 0.5. So that looks good. One thing I might change, we are going to go right to the edge here. I might actually extend the stock. So if we go to stock, let's make this length of 2.25. And then if we go to chuck jaws, we can change the grip length to something like 0.75. And that's better. I'm happy with that. I think it's a safer setup. Okay, I know it's kind of a lot of stock. You know, we do have some stock here that we're going to have to take care of later. There are other ways to do this, but I think this is the quickest operation for us. We're not going to part this off. We could actually grab closer, but I want to keep students away from the chuck jaws. You know, I'd rather leave clearance here and not hit the jaws than hit the jaws and try to save a little bit of stock. So that's my theory there. In reality, if we're making these parts for profit at a machine shop, we would leave less material, in my opinion. So toolpath group 1, we'll just call this turning op, or just op 1 for now. And let's face this workpiece. So go to facing, and I'm going to use the standard roughing, the CNMG insert 80 degree rhombus, green check. Feed rate 10,000 fine, spindle speed, probably 500, still reduced, but it's fine. Cap it at 2,000. That's good. Coolant should be on, that's good. Face parameters, everything here should be okay. I'm not going to worry about deburring it because we're going to be turning. So hit green check, and there's our phasing operation. Good time to save. I'm just going to save this on my desktop as live tooling example. And then I'll transition here, allow you to catch up, and we'll go back and we'll turn this, and we might turn this on a little different method than we have in the past. Alright, so let's take care of deburring this part first. We have a couple of sharp corners I want to take care of. And like I had done in previous modules, I'm just going to go into solids and constant 1 fillet. We'll select that corner and that corner. And the radius will be 15 thousandths for us. That's usually pretty good. Green check. So now we have those filleted. So now we can get ready to turn this. So just to do something a little different, we'll go to turning, and instead of doing the regular rough or finish, we'll actually post this out in can cycles. So let's do a canned roughing cycle. This would be outputting G71. So we'll go to can cycle. We'll select the radius, the fillet here, change direction, and then select the end here, and it should select. If it does not, I'll usually just get out of here, go back to this one, and guide it with the arrows. just like that, and we'll hit green check. Use the same tool that we faced with. Same speeds and feeds will be okay. Again, it's reduced, but it's fine. I'd rather have, I'm not sure how much experience people are going to have running this. From a programming standpoint, it's sort of irrelevant. If you're just programming, you're not going to be running this in the shop. But I'd rather be a little conservative with speeds and feeds for people running, in an educational environment. So canned rough settings, stock to leave in Z and X 10 thou is fine. Depth of cut will go 0.050. Everything else looks okay. The only thing I want to change is going to be lead in, lead out. I want to extend the lead out a little bit, let's say 0.030, just to make sure that it cleans up later. Shouldn't make a huge difference, but I don't want to leave. We will radius out. I just don't want to leave any radius there or anything like that. So that's good. Everything here looks okay, but notice it prompts us for a 2-line format. G71. The Haas is probably going to output a 1. I gotta remember that, but anyway, that's what's gonna happen. You could change it to longhand, but this is the output G71, which is great if somebody's gonna be changing this program later on. It's just another way to do it. So hit OK. There's our roughing cycle, so we could actually watch both of these right now in backplot. So here's our facing up. Okay. Now, in theory, we could have left no material and that would have finished the workpiece, but we'll do a finished workpiece just to have the G70 be put in our code. The other thing I want to bring up is that I know that the part is 3 inches and does have a plus tolerance on it, but the stock we're going to use for this in the shop is 3 inch, so I will either change the tolerance of that or we'll just live with it. I don't want to end up going to 3 1/4 or 3 1/8 because 3 inches is the standard stock size we have at the college, so that's what we're going to live with for this. That's why it is the way it is. So there's a roughing pass. Okay, so let's just take a look at this right now. We'll post this canned rough alone just to make it simple to look at. And you will see your 1-line G71. P100, and it posts it right out like you have done in the past, doing this longhand. So that's another way to output the code. It's shorter, it's easier to edit, but for right now, I'll transition here. We'll take care of the finishing passes. Alright, so back into Mastercam here. Let's just do a finish operation. Now the nice thing about canned finish is that there's no chain selection, so I'll turn the visualization of the roughing off. Let's go to finish, and notice the same tool popped up. We'll rough and finish with the same cutter. Let's update the speeds and feeds a little bit. And then look at the parameters, nothing much here. So let's hit green check, and this is going to look okay. We'll look at the code, but then we're going to have to come back and fix it in a minute, and I'll show you why this is here. So hit green check. And notice this leads in right here, and if you look, it's leaving a little bit of stock. So that's okay. If we verify this, it is not the end of the world, but because the initial pass, there it is, there's a finish. So you see, it's not quite cleaning up the radius how we want it to, okay, versus this radius, okay. But what I want to show you, and again, that could be okay, it's only deburring. It depends on what you want, and there are other ways around that, but let's take a look at these two operations in code, just to show you this. Alright, there's our G71, our lines of code for it. Okay, all the way to 110. Z1.0, then go to G70, which will loop back to here, and there's your feed rate changes for the finish pass in here. Alright, and that's it. So there's G70, G71. Now, there are some options here, but I want to show you what would happen, why that permanently changes there. Notice, this is a problem, let's say. We don't want this. The canned parameters in the rough won't allow that for whatever reason. If you click this, and this is why it's here, click this and hit green check, it goes into a regular finish toolpath, and now look where it is. Okay, Notice it verifies right. It turns it into a standard finish toolpath, not G70, without having to go back and rechain it, which is kind of handy. It's also in the roughing, so if for whatever reason you don't like it, you can go back and not have to reselect. It's sort of handy. So now if we select both of these and post the code, and actually before I do that, let's verify everything just to show you the difference. Face, rough turn, canned, and then finish turn, and notice it's a full radius. Okay, so we're good there. Let's post only the OD work. Take a look at the code differences. Alright, so we got our G71 going through, right through line 110, changes, and there's our longhand finishing, right there. Okay? So it's a little different. Okay? You know, it works good. You know, let's double check our G50s, S2000, that's good. The only thing that I'm not a fan of is the G97 spooling right there. That should turn the spindle to S2000. It's not the end of the world, but it'll probably... it could speed up or slow down depending on where we're at and what the constant service feed works out to. But I'm cool with this. Being that it's one tool, the G50s are limiter, we're good to go. We'll live with it. But yeah, so that's essentially what happens with that. Either rough in the can cycles, either the rough or finishing that permanently change. It's permanent. You're into a finish pass with all of your control that you normally would have. So that's our example for that. So hit save. And this part is roughed and finished, so I will, again, save, transition, and we'll come back to a stock flip and get into the second operation. Alright, so let's get ready for our stock flip. Let's get our view sheet set up here. So I'm just going to save view sheet bookmark and rename this as op1. And then we'll get into our levels, and this will be part op1. And then in toolpaths, we'll do a new toolpath group, and it's going to be stock flip. Alright, let's select stock flip. We're going to select all this geometry. And then the transferred position, we'll start using the select icons, is going to be to there. And then the final position is going to be here. The diameter is 1.980. Hit green, check. And that is our next op. These jaws would be soft jaws. If you're in lab, you're going to have to bore these first, and you have two options. You can write a little G71 code to do this. You could use the Haas, the quick code in the machine, which is fine. You could also write a little macro, and depending on where you are in the curriculum, we could work on that with variables. It's up to you. You could even do it in Mastercam, but I think in mid-process is kind of a waste. I typically either use G71. I have a file that I use that I saved, that I use over and over again. Or I use the quick code, depending on what brand of machine I'm running. On the Haas, the quick code's pretty decent for stuff like that. So that's what I would use. The jaws would not be stepped, they would be flat, but we're going to stay away from it anyway, so there's no sense in getting that kind of accurate in our verification. Just know that you can't void, you can't go past this boundary, and we should not. The only thing that I'm worried about is when we go to drill these holes, I don't want to hit the jaws. So if we go to stock flip, and the transfer position 1.075, it's the Z is minus 375. Let's change that and let's go to 350 and let's just see which direction it goes. Wrong way, so it's going to be, let's go 0.4, and that leaves us a gap. Okay, now that gap still may not be enough. Okay. So notice again, it depends on where the holes lay. One of them's going to hit it. They're going to hit the jaws. There's so many holes there. We can add it. We can go a little bit more, 425. All right, and we'll just have to keep an eye on it. It depends on if we're going to end up using a drill or an end mill, and what the angle is. We might have to change that. So let's just leave that for now. And actually, I am going to tweak that a little more. I lied. So let's just go 450. So that's good, okay? And then you'd have to make sure you space that at the machine before you run it, okay? And again, it's not the end of the world if you went to 375. If you're okay with drilling into the jaws occasionally. As long as the jaws, we're far enough away from the corner, it shouldn't matter. The other variable is, if you want to do that, I recommend facing the jaws, then boring them. That way, that when you gotta want to make sure you leave. This would be a sharp corner in the jaws. You would have to make sure that you chamfer the jaws. Now, that's a much more rigid setup, and if you're in lab class, I definitely recommend doing this. But make sure you talk to me about setting up the jaws and how to cut the jaws. And we're going to leave it in this for programming because we're there. But make sure that you talk to me before you run the jaws or create the jaws, because there's variables you got to think of. If you want to run this rigid setup, one, you got to be good with drilling into the jaws. Two, you got to prep this corner to make sure it doesn't rock on the corner. And three, you got to make sure you face it so that the bore and the face of the jaws are square, so that you're getting double contact, face contact, and diameter contact on the part, which is a rigid setup. You just got to prep for it. So we'll leave it there for now. Facing to zero is not a big deal. What I typically would do, now again, it's kind of nice, if you are pushing the part to the jaws, you could touch a tool to the jaws, come back the thickness of this flange, which happens to be 3/8, and then set your zero that way, your G54. Or you could face this and measure. There's a lot of different ways to find zero here. Again, talk to me in the shop, and we can address that at that point. But I need to know your process plan if you're in lab and manufacturing this. For programming, this is what we're doing. So that's good for now. All right, we'll do a new machine group. Or new toolpath group, I'm sorry. New toolpath group. I'm going to stress that. This is op2. And we'll do a new view sheet, op2. And save view sheet bookmarks. We'll hit save. And I'll transition here and let you catch up, and then we'll come back and face this and do some live turning. All right, let's get ready to face this material off this workpiece. So we'll go to face. Select the same T101, face parameters, use stock. Let's just hit green check. All right, we have a problem. The chuck has been repositioned. We know that. Between two tool paths, use the same tool. The tool is not necessarily retracted to the same start point, whatever. You have options. Either go to save recheck point or select force tool change. Let's do force tool change, and what that does is it forces a tool change op to occur as if it was going to change tools. So just select force tool change, and this is kind of handy on mill too. If you got the same tool doing multiple ops and you wanted to go home for an MO1 in between each op instead of putting like MOOs in, force tool change will do that. So it's green check, and notice it works. Now the only problem is if we watch this, it's trying to take it all in one shot, which is obviously not going to work. So we need to go into parameters, okay, face parameters, and then as far as the roughing, let's take 50 thousandths a rip and finish step over. We'll leave, just leave it there, or turn it off. I'm sorry. We'll go 50 thousandths rough step over, hit green check, and notice it roughs. All right, we're going past zero. That's good. So we could have done a can cycle. That notice there there should be. I guess I lied. Can rough. You would just have to change the. I'm not going to change that. But if I show you up in this one, the rough direction would change it to a facing program, just like you would for boring or whatever you're doing. Okay. So we'll get out of here. Minimize op1. Go back to op2, and make sure that we bring our cursor with us so that the stock flip and the orientation goes with us, just like we did before. That red cursor again pretty much processes the workpiece. So we'll turn this off. So now we're faced. One thing I want to do in that facing op is deburr this edge. So we'll go back into parameters and go to corner and change that to 15 thousandths and hit green check. Now it's going to do that for each op or each slice of this, but it's not a big deal. You're not gaining, you're not losing that much. Okay, so we're good there. Okay, so let's get ready to do the live turning. Okay, and again, don't worry about this OD. I'll either reduce that in the drawing or we'll update that. I'm not really worried about it. It's just that we use 3-inch stock at the college. We order it in bulk, and that's what we're using for this project. This is a mating part for mill part 7, if you didn't already look at the file name, so that's why it is a 3-inch OD. So we'll minimize this lathe face. And now, for the first time, we're going to be into the C-axis command. So I'll transition here, and we'll get into some axial toolpaths. Okay, so let's do some drilling on the live tooling lathe. So we'll go to face drill. Okay, then what I want to do is I'm going to select these holes. Now I'm just going to go through and select them. There's not that many, and I like the control of it. If I have a ton of holes to do, you can do mask on arc and these other things, but I think for simple things like this, it's easier to just control it. Okay, green check. So the tool we're going to use a spot drill. So we'll go to filter, and we'll go to spot drill. 3/8 is fine for this. That hole size I think is 266, so 3/8 would work. 3/8 spot drill is fine. Green check. Make sure that this is going to be tool. We have to sync it up to what. There's only certain tools on the machine that are live. So we're going to end up going, let's say, tool, I don't know, tool 8, let's say. I don't remember off the top of my head on the ST15 that we have what tool that is, so you might have to change that. This is aluminum, so these speeds and feeds are okay. This should have 2 flutes, and the other thing we got to change is the tip angle at 118. And we'll put it down to, it says 4 flutes, we're going to go to 1 to finish. So the updates will reduce that feed rate even further. Again, we're going to go nice and easy, being the first time you're running a live tool. 4,000, we'll go 2,000. Just nice and easy. I forget what the limits are on the ST off the top of my head, so we might have to mess with that, but 2,000, we could even go 500. Because this might be thinking, let's see what it thinks. No, we're good. We'll go 500, nice and easy. Again, these are not optimal in any way, but for the first time running live tooling, I don't want to break anything. In this shop, there's only one live tooling machine. If it gets broken, we're down. That's it. So we'll go cut parameters, drill counter bore, linking parameters. We'll go incrementals from the top of stock for these two. Incremental top of stock is 0. That's where we selected. That's good from chain geometry for these two. We'll do a finished diameter of 0.275 and overwrite the depth so that we get a little bit of a chamfer. Tip comp we don't need. Planes is fine. Coolant can be on. That's up to you if you want to be able to see or not. Down on the bottom, we have different controls for what kind of motion we want. Do you want the Y-axis to move around the workpiece, the X and Y, or do you want the C-axis to work? We'll select the C-axis so that the X and Y, or the X, depending on what it needs, will move. It's mostly going to be the X, and the C-axis, the chuck, will rotate. So we'll leave it there, and we'll hit green check, and we can post that differently. That's up to you. We'll hit green check here. There's our op. So now we can actually watch this in backplot, spot drilling on the lathe. I'll actually watch that and verify quickly both operations. So it faces, slow way down, and then watch as it spot drills and rotates the C. Notice the tool's not moving, only the C axis is moving. Okay, so now one of the keys here is that if we go into here and post the code, you will see C-axis moving. You also see some other commands in here. And again, you gotta watch this because you might have to change the direction of the live tooling, things like that. Different M codes, your different RPM values. P is 500 RPM. Should be clockwise M133 if I remember correctly. Get into the rotations, move to Z quarter inch, C 30 degrees, X 2.5. Should be unlock the C axis, remember correctly. Then it gets into G81 and then all your C locations. Okay? Then it continues on. Now, let's take a look at this with the other option for the rotation. So if we go to Y-axis, because our lathe does have a Y-axis. If we post the code, it's going to be a little bit different. Notice that it looks very similar, except for the fact that their X and Y moves. Okay? So you get the idea there. Alright, it's a little bit different. Spindle on's a little bit different, things like that. But for the most part, C0. That checkbox does drastically change the program, but we'll leave it on C axis. I think it's a little bit cleaner of a program. Okay, the Y axis, I forget how much travel, it's not much. So we'll go with the C for something like this. All right. So there is the spot drilling operation. I'll transition here. We'll come back and drill the holes, and then we'll actually mill the counterbores. All right, so let's go ahead and copy and paste that operation. And we'll get in here, and actually I'll rename this just to stay organized. It'll be drill. And this one will be spot drill. Okay. So now we get into here, and let's change our tool. And this is going to be tool 8, 9, probably 10. But again, double check at the machine. I don't want to do that. Let's do another tool here. I'll change it in a minute. I'm just going to find the tool first. So we'll go 0.266. I'm not sure off the top of my head. Letter H drill. Perfect. Green check. Let's change this to tool 10. And then 500 RPM at that chip load's fine. I will double check and make sure it's only one flute to get that conversion to IPR. That's good. Actually, reinitialize speeds and feeds. That's good. 500's better. So we're good there. All right, that'll be fine for us. Again, not optimal. All right. Cut parameters. We'll go to pec drill. First pec 0.1. That's fine. Actually, we can just go 0.05. Get a little more motion. Depth is going to be all the way through, and we'll put tip comp on and break through 10 thousandths. Coolant will be on. Axis control C axis, just like the other op. Green check. Looks good. So let's watch this operation and verify. Good time to save. Let's watch the drilling ops. So the facing, the spot drilling, and the drilling. Now, collision occurred. Yes, it hit the chuck jaws. We know this. So what I'm going to go is stop conditions and just turn that off for this one. Okay, that's the way we're programming. If you want to put the space in to allow this, that's fine. But sometimes it is okay to hit your fixturing. Okay, we're only hitting it by the drill tip to get a good part. We're not plowing through the workpiece. We're not hitting too much. And actually, we'll take a look at that now. If we get out of here and go to the front view and turn these off, turn this one on, and then make sure we're on top view. I went to front accidentally, so there we go. And you can see, if we go to home, analyze toolpath, I like to make sure the tool's darker so I can see it. If we click the bottom, you can see how far away you need to be. Okay? 370 or 464, 9 minus 3/8 would be our number. That would be the spacing you need. And that's fine. It's just, I think that for us, it's the safer setup and a little more work or practice to create proper soft jaws. So we're going to leave that alone. We'll accept the fact that we're going to hit the jaws for this op. And it is what it is. So we'll hit green check. And those jaws are aluminum, so we'll be fine. So there's the drilling. So I'll turn that one off. And now we can get into the milling operation. So I'll transition here quickly, and we'll come back and do the contour toolpath for all of these counterbores. Okay, so these counterbores look like a 400 thousandths diameter, so we'll end up using maybe like a 1/4 inch tool for that. So we'll get back into our turning example. Okay, C axis, and I'm gonna end up going into face contour. All right, I will select all of these. Now notice that's the way we're going. That's going to be the wrong direction. So if you go this way, that's better. So we're climb cutting. If you plan a little bit with your curve selection, you can save yourself a little bit of time. You can always go back and fix it. But so there's that. Tool is going to be, let's say, a 1/4 inch end mill. So we'll get out of here, go to here, equal 0.25. There's a 1/4 inch end mill there. This will be tool 12. All right. And we'll do a spindle speed. Let's just go 1,000 RPM, and let's do a chip load of 1/2 thou for now. Nice and easy. I mean, that's still slow. Let's just increase it. 1 thou is fine. Nice and easy on this one. Again, not optimal. I know I sound like a broken record, but somebody's going to leave a comment saying those speeds and feeds are out of whack. Well, you know, again, I only have one machine to work with, and I got to get so many students through it. I'd rather have successful parts made and, you know, people learning how to use a machine than try to go fast, break the machine, and be down for a semester. So cut parameters, we're going to do a wear comp. We're just going to finish this out. Depth of cuts will end up going, let's say, I don't know, 50 thousandths each time. Lead in, lead out. We're going to turn that off. And actually, being that the tolerance is wide open, just to keep this simple, plus or minus 20, we're even just going to make this real easy and go to computer comp and not have any cutter compensation. We'll have no lead in, lead out. Breakthrough, don't care about. Multi-passes, not a big deal. Depth is going to be right there. Everything else should be okay. Arc filter we don't need. Planes are fine. Coolant should be on. And then our axis control, we'll do C-axis again, green check. Okay, so what's the problem? Why are the holes so big? Let's go to geometry, and notice they're on the wrong side. So what I'm going to do is select everything, and change side, and then hit green check. Regenerate the operation. Toolpath looks much better. Okay. So there's our op. Alright, let's go to backplot and watch this run. Actually, I'm going to slow that down and just use the S button to go through. So it's going to go in, it's going to plunge 50 thou and cut around. Plunge 50 thou, cut around, plunge 50, and go on through. That should be okay. The only other option we have is to control our plunge points. Okay, so let me transition here, and we'll work through that. Alright, so I'm going to turn that toolpath off. And let's put some points in the center of all these. Okay, so go to point position, point. Put points in the center of every counterbore. And that point is going to be in our chaining to help define the start point. Because if we plunge in the center, the hole being 266, a 1/4 inch end mill will have no issues. It won't have to plunge. You can plunge almost as fast as you want it to because there's no material there. So hit green check. And then we're going to rechain all. And then you're going to select, with the chaining option, select the point, select the arc. You can change direction. Hit apply. Point, arc. And you might be able to keep going, but I'm going to break them up. Apply. Point, arc. And just keep going. And again, careful selection of the points, because that is defining where the tool is going to plunge. And the way we do that is not only with chaining, giving it that point, but we will turn lead in and lead out on and select one of the parameters in there. So they're green check. So make sure the tool is on the right side. We look good. Green check. Go to parameters, and in lead in and lead out, make sure it's on. I changed the overlap up to 20 thou. I also, when I turn this on, make sure the length is 10%, arc is 10%, make sure it's small, and then make sure use entry point is on. Make sure that's on. And now the other option you have now is, because we're using lead in lead out, you can put wear comp back on. That's fine. You might get cutter comp interference depending on how much you're trying to compensate, but since we're moving 10 thousandths and we're using wear comp, we should be in good shape. If we hit green check and turn the toolpath on, you'll notice that the lead in lead out is coming right from center. Again, if you lose these and hit green check and regenerate, that's no good. We want to plunge at the center, and that's where this use entry point and the definition of the chain comes from. We gotta have the points in there. So there it is. Okay. So if we go to isometric and then watch this operation, not verify, I didn't mean to do that. If we just go to backplot and go to S, notice it's plunging right in the middle and working its way around each time. Alright, and if I look at the times quickly, it's only 11 minutes for the cycle, so I'm not worried about the speeds and feeds. Again, they are very reduced. 50 thou depth of cuts is fine. Tool, yeah, slow. So we're good there. Okay, so we go to top view. Good time to save. Select all of op 2, and let's get into back or verify. And we'll go like that, and hit play. Face it down. Spot drill. Drill. And then circle mill. Alright, so that part looks pretty much complete. We have the deburred. The only thing I wish we could deburr would be these two corners here. The reason I'm not going to do that is because this is not like a milling machine, at least our setup, where you can change tools in and out. We only have so many live axial holders, and we're already using 3. So there's going to be one for the spot drill, one for the drill, one for the end mill. Maybe if we use a carbide drill, we can get away with, you don't have to spot drill, and you could use another tool, have another axial holder open. But deburring toolpath here is not a big deal. If you get it, would be the same idea, and then the cut parameters, 2D chamfer, just like you would on a milling machine. So that's it for this one. If I go to top view, save again, there's your op 2 toolpaths, and that's axial. Those are axial live tool or C-axis turning or Y turn, whatever you want to call it. Live tooling on the lathe. There's other options here. We use face contour, face drill for axial toolpaths. The one we did not play around with is going to be the radial tool, so the tool will be coming in perpendicular to the axes of rotation, and perhaps we'll get into that in a later module. But that's it for this one. If you have any questions, let me know, and thanks for watching.